So we were talking about frequency. Frequency is the number of crusts or trough that pass a point per second. It is equal to the number of complete waves generated per second. The unit of the frequency is hertz. Hertz is equal to per second. It also be no, it should also be quoted over here that frequency is the reciprocal of time period. So what is frequency? Frequency is the number of waves producing in 1 second. Let's suppose this time is 1 second. Here it is denoted 1 second here, and here it is 0.5 second. So in this one complete second, how many waves are producing? There are two waves producing in this 1 second. 1 and 2. Here was 1 second completing on the axis. So in this one complete second, there are two complete waves producing. So what does it mean? What is the frequency of this wave? 2 hertz, because two waves are producing in 1 second. So this was all about frequency. Now what is wave speed? Wave speed, the speed v of the wave is the distance moved by the wave in 1 second. Fine. So the distance moved by the wave in 1 second is equal to the wavelength, and the distance moved by and the time taken by one complete wave, or time taken by the wave to cover distance equal to the wavelength, is equal to the time period. So v is equal to lambda divided by capital T for time period. So this is the formula used to find out the speed of the wave. This can also be noted, this can also be written like v is equal to f lambda. What is f? F is the frequency. So here this 1 over t is basically the reciprocal of time period. So that 1 over t can also be written as frequency f that they have written. So instead of writing 1 over t, they have written f frequency, because frequency is the reciprocal of time period. So the formula for the wave speed becomes v is equal to f lambda, frequency into wavelength. So we can say that wave speed is the ratio between the wavelength and the time period, or wave speed is the product of frequency and wavelength. So this formula would be used further in different examples to find the speed of the wave. Next is displacement position graph. This is so easy, and in this graph you will plot displacement along y-axis and position and the distance covered by the wave along the x-axis. So this graph, the main point, the main thing to note is that this graph will tell you about the amplitude of the wave and the wavelength of the wave. You can use the displacement position graph to get the wavelength of the wave and to get to know the amplitude of the wave. How would you find the amplitude? You will find the amplitude by taking the measurement from the vertical axis, from the displacement axis. You will see that what is the height of the crust from the vertical axis, and you will measure the height of the crust, that will be the amplitude. And for wavelength, you will read the distance axis, the position axis, the horizontal axis. In this, you will measure the distance, you will take the distance between two crusts. Like this distance is known as wavelength. Next is displacement time graph. This graph is used for two things: to find the amplitude and to find the period of the wave. And by finding the period, we can, taking its reciprocal, we can find the frequency of the wave. So this graph is useful for amplitude and the period. In this displacement time graph, the displacement again is taken along the vertical axis, and the time is taken along the horizontal axis. Fine. So how we will take the period of the wave? We will just measure the time between the two peaks, or time between the two troughs. The time between the two taken by completing the two peaks, here between the two peaks, is known as time period of the wave. So it was all about displacement time graph.